over here while we give it a second. Oh, we're live. All right. So now I'm trying to multitask. Get that. Right click, show the controls, make it big, and check roll over here at the same time. You do need a calculator just for like the last problem here. And I don't know, we may need the calculator on the next page too. So anyway, attendance, everybody came. That's so heartwarming. Okay, move this guy out of the way. Grab the calculator that I'm sure I had. There you go. Thank you so much, sir. All right. Last couple of problems are using this. What does that F stand for?
Grade resistance.
Grade resistance. Why do you think they use an F? Okay, because it's a force associated with the force of gravity. Okay, and W is the weight of our vehicle, right? So anyway, we set up the formula, the bell rang, correct? You slap that puppy into your what should we do before we just take off with these calculators? Make sure our mode is in degrees. Okay. So now 2400 sine of a negative, is that a 2.4? Okay, 2.4. And I don't have to tell the calculator degrees because I already told it degrees. If I had minutes in there, I would need that to separate the two units. All right, what we're coming up with for the force? Are y'all just going to let me type this in for you?
No, it's negative 100.502.
Okay, were we given a place to round?
No.
Okay, I went with the Stewart standard. So the force was approximately negative 100.502 watts.
Pounds, yeah.
Yeah, it's the force is measured in pounds.
I wrote pounds yesterday, and it looks like 502.1 BS.
1 BS, okay. Well, I used to teach when I taught elementary school and kids couldn't remember how many ounces were in a pound. I'd say, look, pounds, it looks like a 16. And the little thing, you know, all right. Any idea why on earth they abbreviate pounds with LBS?
No.
It's Latin. So, you know, your zodiac symbols, Libra is the weight. Okay, so it comes from Libra, right? All right, because your language is more based on Latin than mine, correct? All right, so moving right along, we're going to have one where we work backwards this time. In the last example, our car is traveling on the -3 degree downhill grade, and it has a grade resistance of negative 145 pounds, and we want to know the weight. So how are we going to set this one up?
Weight equals negative 145 over the sine of negative 3.
Okay, so you've already simplified it. I'm going to go to my formula and then I'll jimmy-jammy it all around. But what we've been given is the force, which is negative 145 that goes on this side of the equation. We are missing the weight, which happens to be multiplied times the sine of -3. We don't always put parentheses around the argument, but dang it, if it's a negative, I certainly would put that around the argument. Something that you may not have thought about yet, so file this away. Do not try to never separate the trig function from the angle. You can't. They are a unit. They belong together. That's why when you hit the sine button in the calculator, it pops open the parentheses. Sine of what? Okay? So it's not sine being multiplied times a -3. It is the sine of a -3. So it's an argument there. All right? And to get, okay? But you don't actually have to type in the degree symbol, do you? Okay? So our weight, what you coming up with for that?
2,770. 270.562.
Okay, I got 2770 and you rounded to 562. And what's our unit here?
Pounds.
Pounds. All right, so that wraps up our 2.3. So the 2.3 homework is officially due tomorrow, but if you did it last night anyway, because you didn't check the email and you turned it in, because it wasn't really rocket science from this point forward, it was just a little bit of algebra, yay. But if not, make sure it is in tomorrow, okay? So let's flip the page and let's examine 2.4, which is solving right triangles. So there's going to be a portion of this that we work in the typed notes section, and there's going to be a portion of this that we work in the notebook. But before that, in my hand, I am holding an assignment. The title says Trig Worksheet After 2.2. I want you to add to the top of that major break. Okay? We lost a whole stinking week. Oh, snapperoonies. Wait. I think that is hold the phone. Hold the phone. What is happening here? I didn't tell the copy machine to staple. That's what's happening. So let me give you 2 pages and you staple them together, okay? And then pass the stapler along. All right, so a first page and a second page for you, a first page and a second page for you, a first page and a second page for you. So it's gonna be major. I'm gonna come over here and grab myself a red marker. Okay, so up here. I'm going to move that up so it's not taking up so much real estate. Okay. Major worksheet after 2.2. That is really not a great description, but there's your description. Major
Good
worksheet.
morning, please rise for the pledge.
Remind me, I was about to tell you the due date for that.
I pledge allegiance to the flag
Of the United States of America and to the republic for which it stands,
one nation, under God, indivisible, with liberty and justice for all. Now the Texas flag. Honor the Texas flag. I pledge allegiance to the Texas, one state under God, one indivisible. Please remain standing for a moment of silence. Thank you, you may be seated. Reminder, we do not lock doors open on this campus for any reason ever. If you see a door propped open, please close the door for our safety. And teachers, please check for dress codes. If there are any issues, please come to the office. Ms. Long needs to see all 7th and 8th grade student council members today at some point during class changes. Junior class, there will be a meeting today in Ms. Ayers' room during the advisory. Please make plans to attend. Also, early college high school applications are due this Friday by 8 a.m.
Thursday.
This year, BPA will be selling teddy grapes. Orders will be delivered to students' homeroom or advisory period on Valentine's Day. The teddy grape auction. Option 1, a small teddy bear with artificial rose, small candy bag, and a personalized message for $10. Option 2, a large stuffed teddy bear with extra candy and a personalized message for $15. And option 3 are both options A and B for $25.
And y'all shopping for me for Valentine's.
Tonight, our Pirate basketball teams are hosting Evadale. JV boys start at 4:30 and varsity teams follow. Tonight is also our girls' senior run, so please come out and support if you are able. Today is Creative Vacuum Day and National Quacker Day. Today is quote of the day. The best preparation for tomorrow is doing the best today. Thank you, have a great day.
Right here, like up here, and then like if I breathe in really deep, like down here, and then my throat just hurts, and I'm gonna stop.
move you and your little germs far, far away
Yeah,
from
maybe
everybody.
you just by yourself somewhere.
Maybe share the love.
Directly in the middle of the
Where's your
class.
mask? Oh, gosh. Okay, well, I'm glad you're here.
Let's get through that.
I'm not glad your germs are here, but I do appreciate your dedication. Okay, so you guys, this normally probably would have been done a day in class so that I could make sure you were not using your notes and your unit circle. I'm putting you on the honor system here because we've lost a week and I don't have time to sit and stare you down. But the point of this exercise is for you to dig deep, especially when you get to this back page and you start practicing finding all the values of these angles that could be anywhere on the trigonometric circle, okay? You've got a little list of tools from the other day to help you. If it's a sine or a cosine, I'm sorry, it's just the x move or the y move, boom. If it's a tangent, you might want to make a complex fraction with the x move over the y move.
One,
Well, if it's out in the, no,
one of it.
candy for you, Bubba, okay? If it's a tangent, the y move over the x move, and if it's not quadrantal, in that case, they're both fractions with the 2 on the bottom, right? Square root of 3 over 2, or 1 over 2, or square root of 2 over 2. So you don't really need those bottom numbers, right? Look at me. People miss these because they forget the quadrant they're in and they don't put a negative when, and it'll be completely wrong if it's negative and you don't put a negative. What are you gonna do if it's secant or cosecant?
That's what I'll tell you about the whole thing.
Okay, what do you do if it's secant or cosecant?
You get this kind of close, I
Turn it over, yeah, change it to cosine or sine, work it, and then
flip it back.
flip it back, right? If it's quadrantal, I just use my X, Y, R, you've got an X, you got a Y, and if you need an R, it's 1. Okay, so you're dealing with zeros and ones and negative ones there. So I think that pretty much covers what you're dealing with, all right? Deal with it carefully. Slow and good, because you have all the time in the world, you have the Thursday, beats fast and wrong. Okay? That, you've been warned. It is major. This could be a great money maker because the next major grade is, I still have it planned for Monday, and that's the test. And that's a real test there. Test that you test. You've got to come out your head, right? So, all right. Now, let's move on. We're solving right triangles, and I mentioned this a little bit the other day, solving right triangles. That is going to be something we see come up a few more times this year in trig. I also showed you this particular triangle the other day where A, B, and C, capital letters, were the vertices, were the points of the corner, and the little a, b, and c are on the opposite sides. We'll see this triangle again and again this year. All right. One more thing. This has a cat homework, and I don't think I'm going to totally get through these notes today, so I'll probably let you know when this one is due. Probably going to be due Friday since we've got a big thing Wednesday, a big thing Thursday. Let's just go ahead and write that cat homework will be due Friday, and so Friday would be to 7, right? All right, I want to jump into teaching. I'm tired of talking about teaching. I want to teach, so remind me tomorrow. I need to put that up on the board, okay? When we get rid of a spot and you turn in something else. All right, so solving a triangle means finding the measures of all what's and what's. Sides and angles. Did you say sides and angles? Okay, sides and angles. All right, so you got 3 sides, you got 3 angles. You're looking for 6 things. But have to give you three things for you to be able to do that. Now, this is important. We'll talk a little bit more about it when we actually start going and practicing some problems. So don't worry about that. Your tools, where we were talking about sine, cosine, and tangent at the beginning of the semester as y over r, or x over r, or y over x. Those letters refer more to an angle that's on a trigonometric circle. When you leave the trigonometric circle and you leave the XY grid, and you just have a triangle sitting out there somewhere in the world, we go back to our SOHCAHTOA. All right? So we talked about that the other day. We also have the Pythagorean theorem in our toolkit. If you know two of the sides and it's a right triangle, and by the way, excuse me, draw a right angle in that picture, because at this point we are only solving triangles with right angles in them. But later this semester, I will show you how you can use your trig knowledge using the law of sines and cosines, which you will learn later, to solve triangles that are not right triangles. For now, it's right triangles. So really, you are using tools you had in geometry class. SOHCAHTOA, Pythagorean theorem, and also, what are the sum of all the angles in a triangle? 180. So those are the tools in your toolkit. So for now, we're going to jump to some problems from the book and work some examples. I know you know how to do this, but my main thing is making sure you know what I expect your answers to look like. So 2.4, solving right triangles. We're going to start off with problems 9 through 16. The directions say solve the right triangle. So when you hear the words solve a triangle, you two are like so far away from me. Y'all should be copying this. I'm talking while you have a chance to copy this down. All right, so stop working ahead and stay with me here. When the directions say solve the right triangle, you have to find all missing sides and angles. Now, look at this little cloud here, because they are going to give you, they're going to give you three things, or they're going to give you two things. Yeah, I'm kind of looking at this here. Let me see. Ooh, they aren't going to give you three things. They only give you two things here. Sorry, I lied about the three things. They give you 2 out of the 6 possible pieces of information. So what they may give you is 2 sides. Okay. They always have to include a side somehow. If they just gave you 2 angles, well, I guess they are giving you 3 things. You know why? Because one of them is a 90-degree angle. So in every one of these, the 90-degree angle is given, then they give you 2 things. But look at me. They can't just give you the 2 other angles, because you have to know one side to know how to scale how big that triangle is. So you will always have at least one side given to you, but the other thing they give you might be another side. If 2 sides are given and they don't give you any angles, then they want your angle measurements to be given in degrees and minutes. Now, you see my little whiteout glob here? Guess what I wrote just real quickly when I was doing that? I wrote degrees, minutes, seconds. And then I look back and I go, oh, they don't want the seconds. So I whited out seconds, which means you have to round to the nearest minute. Now, if they do give you a side and they give you an angle, your answer for the other angle needs to be in the same format. So if they give you an angle as decimal degrees, you give me decimal degrees. If they give you the angle in degrees minutes, you give me the angle back, the other angle in degrees minutes. That all making sense? Have you had a chance to catch up on your directions here? If not, shame on you for not being focused where we were, because we are jumping in with example 10. And in this first batch of problems from 9 through 16, they draw the triangle for you. All right, so number 10 is oriented this way. My right angle is right there. Bottom corner is A, top corner is B. The right angle will always be capital C. So that makes this side little c, and it's missing. That makes this side little b, and it's missing. If they have to give me a side, so over here, they give me this side as 35.9 kilometers. Okay? That's not enough for me to solve that triangle, though. So since they're not giving me two sides, they give me one angle, and it's this guy right here. Let me see if I can come in a little closer. Okay. No, it's not as focused as it was. All right. This angle is given to me in degrees and minutes. It is 31 degrees, 40 minutes. Definitely using a calculator is definitely a calculator page. Okay? So, what do I not know?
You don't know all of C and B.
Little c, two sides. And what else is missing?
Angle.
What's the easiest one of those to find, do you think? Okay, so let's go ahead and find angle B. I need you to make sure you're telling me capital B, so I know you're looking for that angle. But you can put B, you can put any scratch work you feel like you might need, and then the answer. Probably you're going to do this straight in the calculator. What you going to do to get that angle B?
90 minus.
Okay, why 90? Why aren't you going with a 180 there?
Because there's already 90.
I've already sucked up 90 degrees here. The two remaining angles are complementary to each other, so I can find it with 90 minus 31 degrees, 31 degrees, 40 minutes. You don't have to show me that, but my notes are going to show you that. If you put that in the calculator, it's not going to automatically give you degrees, minutes, seconds. So do you remember how to change it into degrees, minutes, seconds when it gives you the decimal degrees? All right. Does it, it shouldn't even need to round, because if this only had minutes, it's not going to come up with seconds at all. What you coming up with there? Okay, I've got a vote for 58 degrees, 20 minutes, and some head nods. Now, if you just box this, I should be able to go back to where we started and know that was what your B was. Okay? Now, what tools can we use to find little b and little c? That's where we're going to go with SOHCAHTOA. We're going to use our trig ratios. What do you want to find first, the little b or the little c? Little b? Okay. How are we going to find the little b? What do we got? What do we have to work with? By the way, and this is just my advice to you, you could use the 58 degree 20 minutes, but what if you had made a mistake in that? I would stick with the one they gave me. So they have given me an angle. I do know a side. So I need to come up with an equation. Matter of fact, I'm probably not going to put B equals. I'm going to put B into my equation. All right. If we're solving for B, will we be using sine, cosine, or tangent? Okay. I'm going to need to use the side I know. I'm going to need to find this B from the angle I know. What would I call these two sides? Tangent, because these are opposite and adjacent. So my equation would be the tangent of, and we've got a 31 degree, 40 minute angle. I don't know why that's so hard for me to write. I feel like I'm writing the wrong thing, probably because my left hand is covering up what I'm looking at. And that creates a ratio. So what's going to go in my ratio? What's the opposite?
35.
That goes on top
Over B.
over the B. It's been a couple of weeks, but what trick did I give you a while back? If you have a non-fraction equal to a fraction and your variable is in the denominator.
Put it over one.
I could, but I don't even want to mess with that. So my shortcut is the denominator here and the non-fraction can swap places. They can swap places. We did it by putting this over one and realizing that we're cross multiplying. It doesn't matter what's in each corner. This comes up so frequently this year. Just be aware the denominator can swap with the non-fraction on the other side. So B will be obtained by taking the 35.9 and dividing it by the tangent of 31 degrees, 40 minutes. Now, I'm looking for a side. They did not give me any directions at all about where to round off my sides. So what is the Stewart standard for rounding? 3 decimal places. Type that bugger into your calculator. Don't be the person who's waiting for everybody else to type it in. You be the person who types it in. Round it to 3 decimal places. And approximate the length of side B. By the way, they told me a unit here of kilometers, so you need to make sure your answer is in kilometers. What you coming up with as you round it off? It's a pain to type these in, isn't it?
58.
But it's better than having to do it without a calculator. Okay, what you coming up with?
58.203.
I have a vote for 58.203. Oh, and some head nods. Nobody. Double check your math. I would mostly check, did you get the 31 degrees, 40 minutes? Did you type a 35.9 on the top? Are you in degrees? Surely you are.
Oh, it gave me the right answer. I just wrote a 2 instead of a 4.
Okay, so what are we going to get in here? 58.203 what? Kilometers. Now, what else do we need to find? Side C. How do you want to go about finding side C? You said Pythagorean? Could we use Pythagorean theorem at this point? Okay. All right. If we're using Pythag, there's going to be some rounding involved because we're squaring and we're square rooting. But the rounding should probably still come out the same as if we went back and used a trig function and said, well, this time it would be the sine of 31 degree 40 minutes because it'd be opposite over hypotenuse. So either way, you're going to be typing some stuff in. Y'all want to go with Pythag? Okay. So if I'm going to go with Pythag, what? You don't like the Pythag? You want to do it the other way? You do it? Okay. All right. If you are going to use Pythag, we're looking for C. We've kind of gotten where we don't set up the whole Pythagorean theorem, a squared plus b squared equals c squared. If I'm looking for C, what's going to be under my radical? Do I need to subtract this time or add? Because I have the 2 short sides. I'm looking for the hypotenuse. So we would have 35.9 squared plus, okay? You guys, listen to me, listen to me, listen to me, listen to me. Are you listening? Do not use your rounded off number. Y'all rounded this guy off, didn't you? Okay. Never use a rounded off number to make a new calculation. So when you go put this under this, you need the whole thing, 58.20. Was it a 3 or was it a 2 next? Look, I'm just going to put dot, dot, dot. Okay. So I didn't put that guy in my calculator. Can I steal your calculator, please? take the time to type it. Watch me, especially Filippo. I always feel like I'm saying that wrong. Filippo. You may not know this. So if I'm going to go, you know, oh, well, that was not what I wanted to do. Doggone it. Hold on. Ugh. Okay, look, I'm going to go up and get, I just keep making weirder stuff. Okay, that's where we had it a second ago, right? Okay, so we have that answer. Good. All right, so I'm right here. I am going to do second square root of 35.9 squared plus, now, I don't know if you've played with this enough. Okay, you can just go up and grab it. Okay, you got that? You are a sharp cookie, buddy. All right, and that squared. Don't use your rounded off version because you are going to be, a lot of big things are happening and you may be off by a digit. All right, if I go with this, what am I coming up with for my C? Okay. Never, 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 never use an already rounded off number. You know, that's a very strong never statement, which I'm actually going to change a little bit. But first of all, tell me, what did we come up with? 68 point what? Okay, if I were grading this, do you think I could quickly find those answers? They are boxed. Please put boxes around your answers. And I know which one they are by just going back to the beginning of your scratch work. You may not have needed so much scratch work because you may have gone straight to your calculator. Listen to me. When I said never, 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 never use a rounded off number. Look at me. If your expression that you're going to use it in only involves adding or subtracting, you can use a rounded off number. So let's say that you had found one angle, because all you had were sides, you found an angle, rounded it off, and needed to find the other angle. Well, all you're doing is subtracting 90 degrees minus that angle. There's no multiplication or division or squaring involved, right? You could use a rounded off number, the answer will always be fine. But it's when you start multiplying, when you round off, you're starting to make an error, right? You're no longer accurate. When you multiply that error, that's when you start to lose accuracy. Or if you divide that error, you start to use accuracy. Or you square that error, or you square root, then things start to miss those extra decimal places. But if you're doing nothing but adding or subtracting, for example, in the case of finding one more angle, you can use your rounded off number. So never, 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 except when you're adding or subtracting, use a rounded off number. Okay, moving on. Next example is 16. Again, they've given us the triangle, and it's oriented this way this time. I know this is my C. A is the top left, capital B is the bottom right. They tell me this, the hypotenuse in the picture is, whatever, that little picture, 15.3 meters. And they tell me this vertical side, CB, is 4.80 meters. And you may be wondering, why did they bother to put the 0? It's not going to change how I do anything. It may be that they measured it and it was 0.798 and they rounded it up. But anyway, this book has a whole lesson on significant digits, and they continue using it. We just aren't taking the time for delving into how significant digits work. All right. So what do you think is the easiest thing to find right now?
Oh, the other side.
Okay. Okay. What's the name of that missing side?
B.
Little b, right? So how are you going to get little b?
We're going to subtract.
In the Pythag, right? So we're going to square root. So which one has to be first? The hypotenuse. What would happen if we didn't put the hypotenuse first?
It would be negative.
And then what would happen?
Then we get over surprise, but it's something.
No, it wouldn't. It would just be imaginary.
Well, that's not fun.
Okay. That's not as bad as dividing by 0, but it's still difficult. Notice I didn't even bother to put the 0. I don't know why they have the 0, but if I put it or don't put it, it is not going to affect my answer in any way, is it? So we are going to round this to how many places? 3. So what you coming up with, kiddos?
14.528.
I agree. 14.528 meters. Box it so it's obvious. Now, we don't know any angles, or no, that's the lie. We know it's a right triangle because we're still at the beginning of trig. So we don't know either of the acute angles. So pick one that we can begin with.
A.
Okay? If we're going to go with angle A, I wouldn't use the measurement I just found, just in case I'd made a mistake. I would use the measurements they gave me. So how could we find angle A?
Sine.
Okay. Got opposite over hypotenuse, but that would be the sine of what angle? A. So how am I going to find my angle if I can't get the sine of my angle?
We're gonna put one of the other,
We're going to work backwards. So we're not actually going to use sine. We're going to use inverse sine. So are you okay if we go ahead and set it up as inverse sine because we know we're looking for the angle here? So what's the argument going to be when you're doing an inverse? The argument when you're doing the inverse is the ratio. So when you're doing an inverse, you give it the ratio of, if it's sine, opposite over hypotenuse, and then it works backwards and spits out the angle for you. Okay? So what is the ratio that I would have used here?
4.8 over 15.
Okay, 4.8 opposite over 15.3. Now, when you put that in the calculator, it's going to give you degrees because you've already told the calculator to give you degrees, but it's going to give you decimal degrees, isn't it? For the sake of good notes, give me a little bit of what you see there. Like 18 point blah, 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 something like that. 18.2, blah, 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 blah. Are we going to round it off? Because our direction said, y'all look, they didn't give us any angle formats to let us know if they're using decimal degrees or degrees minutes, right? So if two sides were given, so you don't have an angle to say, hey, this is how we're going to do it. This is how we're going to do it. We're going to do it in degrees and minutes. So you need to do degrees, minutes, seconds in the calculator because degrees, minutes is not an option. And does it come out exactly in degrees, minutes, or are there some seconds? Okay, so tell me what you're looking at so I can put in my notes what we're seeing. You're still getting 18 as the degrees, right? 17 minutes and then 2 point what?
0.004.
Blah, 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 blah seconds, correct? Well, I don't want degrees, minutes, seconds. I just want degrees, minutes. How do you round in degrees, minutes, seconds if you don't want the seconds? Let me ask you a question. How many seconds make a minute?
60.
So what would be the halfway mark that would say round up? 30. So do we have 30 or more seconds? So do we round up or stay the same? Okay. But if this had been 18 degrees, 17 minutes, 45.392 seconds, we would have said 18 minutes, 18 degrees, 18 minutes. Does it make sense? So our answer is 18 degrees, and we're sticking with 17 minutes, correct? Now, have we found the 3 things that I need to have boxed? No. So what's the other thing we need?
B.
Okay. And did I ever put what I was looking for here? I really didn't put what I was looking for here, did I?
A.
So what did I find there? So I should have written A equaled. Okay. So what's the most efficient way now to find B? From what?
You do 90 minus whatever.
Now, since your calculator still has this unrounded, you're welcome to put it in the calculator, with the whole thing, but you also could do 18 degrees, 17 minutes. Why am I not worried about the fact that I've already pre-rounded that answer? Because I'm only using subtraction. But you've already got the number in your calculator, so rather than type this in again, you can just bring down the previous one, and you're still going to have to go hit degrees, minutes, seconds on it, aren't you? So tell me what that's going to look like in just degrees and minutes. It's going to be 60.
71 degrees and 43.
Okay. So did you let your calculator do that, or did you do that in your head? Did you say 43? Because that would add up to 60, right? Now I have my 3 things found and boxed, okay? The next little batch of problems goes from 21 through 36. It is the same stuff. It is the same directions. We're solving the right triangle, and again, if 2 sides are given, we are being told to only use degrees, minutes. The difference in this batch of problems is they don't draw the triangle for you. They just make a list of the 2 things they're going to tell you. We will do exactly one of these together. It is number 28, where they give me little b is 32 feet and little c is 51 feet. And maybe you feel like you need to draw the triangle. Maybe you don't feel like you need to draw the triangle. What do you think? What do you know you could figure out real quick without drawing that triangle at all? Little a. How are you going to figure out little a? What could you put in your calculator that would take you straight to little a?
Square root of 51
Okay. Minus 32 squared. Okay. No instructions are given on what to round this off to, so we go to the Stewart standard. Tell me what you're coming up with.
39.71.
I've got 39.711 from one source. Okay. 39.711 degrees. Ha ha ha. Every now and then I can catch people on that. So be on your lookout. Now, could you figure out how to find an angle without seeing the triangle? What if I wanted you to find angle B?
That'd be opposite to little b.
Okay, so angle B would be, all right, so maybe we could look at this. Angle B, without having to draw the whole thing. We know little b, right? We know the opposite, and what else do we know?
Everything.
Well, if I know little c, I know the hypotenuse, don't I? Little c is the hypotenuse. Little b is opposite of big B. Opposite in a hypotenuse, what inverse trig function am I going to use? Okay, but I'm going to use inverse sine because I'm looking for an angle, right? And my ratio is going to be the opposite, which is what? Over, I made that really wide. I don't know what big old fat stuff I thought I was going to stick in there. 32 over 51. And since they did not give me a model for how to get my degrees, minutes, seconds, or decimals, I got to go with degrees, minutes, right? So put it in. It gives you decimal degrees. And then change it to degrees, minutes, seconds. Y'all know where all this stuff is, right? Give me this one before you run out the door. You get it?
38 degrees, 52 minutes.
38 degrees, 52 minutes. We will start right here with the other half of that one. And then we will do the problems that are in the packet tomorrow. Okay? So, y'all got stuff to be working on for me. Keeping in mind your test is coming up on Monday, so you should be visiting that review often because every time you walk out of here, you know some stuff you didn't already know. The test will have a calculator page, so any problems that are from these assignments we did on calculator will be on calculator.
Oh, I'm so sorry.
Bye, teenagers.
Bye-bye.